Hi there! For this video, we'll be talking about how to add and subtract rational expressions. First, what are rational expressions? Rational expressions are basically similar to fractions, but our numerator and denominator are composed of polynomials. So an example of this is, say, x squared plus 1 all over x squared plus 2. This is a rational expression since the numerator is a polynomial and so is the denominator. So let's have this as an example. If we have 5a over x plus 6b over x, like how we add and subtract fractions, if we have the same denominator, what we do is we simply combine the numerators. So this one will be equal to 5a plus 6b all over x. And this is the answer. Let's have this next example. Let's have bx all over a plus b plus ax all over a plus b. Again, since the denominator is same, we simply add these numerators. So we'll have bx plus ax all over a plus b. Is this the final answer? Not yet, since observe that we can actually factor out the x out here. So let's move this one. So this one will actually be equal to, factoring out the x, we'll have x times b plus a all over a plus b. And note that by commutativity, b plus a is equal to a plus b. So we can cancel out this one. We can cancel out this one since we know that a plus b is not equal to 0. Since if it is 0 over 0, then this is undefined. And indeed, it is not equal to 0 since we have this as our starting denominator. So if this one is equal to 0, then this whole fraction will be undefined. And that is not allowed, since if it is undefined, it is not a rational expression. So this one simplifies into x. And that is the answer. Let's have this next example. Let's have 2 over y minus 3 over y squared. Now, similar to fractions, when we have different denominator, our goal is to convert these denominators to be the same. For this example, note that since y squared is equal to y times y, we can actually multiply y over y out here. So this one becomes 2y all over y squared minus 3 over y squared. Simplifying, since the denominator is already the same, this becomes 2y minus 3 all over y squared. That is the answer. Let's try a similar one in this next example. If we have 6 over x squared y minus 5 over xy squared, observe that the denominator is not the same. So what can we multiply in the first and the second rational expression to make this the same? Observe that this denominator is equal to x times y this one out here is x times y times y. So this first denominator is missing a y. This second denominator is missing an x. So we can multiply a y out here and a x out here to make the denominator same. So we'll do that one. So we can multiply y over y out here and x over x out here to obtain 6y over x squared y squared minus 5x all over x squared y squared. This simplifies into 6y minus 5x all over. Since the denominator is same, we'll have x squared y squared. And that is the answer. Let's have this next example. Let's have 5 over x plus 2 plus 3 over x plus 1. Now in this one, we're already dealing with binomials out here. So to make the denominator the same, what we do is, since this 2 doesn't have any common factors, what we do is we multiply this denominator out here. So we multiply x plus 1 all over x plus 1. And for this one, we'll multiply this one. So we'll have x plus 2 all over x plus 2. Simplifying, this becomes 5 times x plus 1 all over x plus 2 times x plus 1 plus 3 times x plus 2 all over x plus 1 times x plus 2. And so observe that the denominator is now the same. So that is the strategy that we will be using to get the same denominator in dealing with binomials. So simplifying, we can now combine the numerators. We'll have 5 times x plus 1 plus 3 times x plus 2 all over x plus 2 times x plus 1. Simplifying this, multiplying the 5 out here and the 3 out here, we'll obtain 5x plus 5 plus 3x plus 6 all over x plus 2 times x plus 1. When simplified, this becomes the numerator combining the like terms. 5x plus 3x is 8x plus the denominator is 5 plus 6, that is 11. All over, you can apply the FOIL method out here, and the denominator will be x squared plus 3x plus 2. And that is the answer for this one. Let's have this next example. Let's have 2y squared minus 16 all over y squared minus 4 minus y plus 4 all over y plus 2. Now for this one, do we immediately multiply y plus 2 over y plus 2 here and multiply y squared minus 4 over y squared minus 4 here? Well, the answer is no. Since observe that y squared minus 4 can actually be written as y plus 2 times y minus 2. How? due to difference of two squares. So we'll need the factoring concepts in this example. So with that in mind, the only thing that we need to multiply in here to make this the same is to multiply y minus 2 over y minus 2. So doing that, we'll have here y minus 2 all over y minus 2. So this one will be equal to 2y squared minus 16 minus y plus 4 times y minus 2 all over, I'll use the factor form out here and I'll explain why later. So we'll have in the denominator y plus 2 times y minus 2. Simplifying, we apply FOIL here. So this one becomes 2y squared minus 16 minus, using FOIL, you can verify that this inside is y squared minus plus 2y minus 8. Yep. And then denominator out here. Denominator will have y plus 2 times y minus 2. So let's erase this one to save some space. Next thing we do is we distribute this negative sign out here. So we'll have 2y squared minus 16 minus y squared minus 2y minus 2y, yep, plus 8 all over y plus 2 times y minus 2. Then simplifying the numerator, combining the like terms, 2y squared minus y squared, that one is equal to y squared. Then 2y out here. Then the negative 16 and 8 to obtain negative 8 all over y plus 2 times y minus 2. Now is this the final answer? The answer is no, since we can actually factor out this numerator out here. By factoring quadratic trinomial method, you can verify that this one in the numerator is equal to y minus 4 times y plus 2. So with that in mind, let's move this one. So we'll have this one as our new numerator. And observe here that we can cancel out the y plus 2. Again, we can do that since y plus 2 is not equal to 0. Since if it is 0, then this rational expression out here will be undefined. That is not allowed. So canceling that one out, our final fraction will be y minus 4 all over y minus 2. And this is the answer. So that is the reason that on why you shouldn't simplify the denominator immediately at this step out here. Let's circle that one. At this step, since if you try to simplify it immediately, you won't be able to see what factors you can cancel out at the end. So let's clear this one out. So let's have this one last example. Let's have 3 over x squared plus 2x plus 1 plus 1 all over x squared plus 3x plus 2. For this one, to know what to multiply, observe that this one out here is a perfect square trinomial. And you can verify that in factored form, this one is equal to x plus 1 squared. On the other hand, this one out here can be factored using our factoring quadratic trinomial method. So you can verify that this one is equal to x plus 1 times x plus 2. So with this one, we know, since we can write this one as x plus 1 times x plus 1, what we need to multiply in this one is, we need to multiply an x plus 2. And for this one, we are missing another x plus 1. So that's what we need to multiply out. So let's fix this one. So for the first, we'll have 3 over x plus 1 squared times, we need to multiply x plus 2 all over x plus 2. For the second rational expression, which is 1 over, and simplify, the denominator is x plus 1 times x plus 2, we need to multiply x plus 1 all over x plus 1. So simplifying, since we already have the same denominator out here and out here, we'll have the numerator will consist of 3 times x plus 2 plus 1, or simply x plus 1, all over x plus 1 squared times x plus 2. Simplifying the numerator, we'll have, distributing this 3, we'll obtain 3x plus 6 plus simply x plus 1 all over x plus 1 squared times x plus 2. Combining the like terms, which is 3x and x, we'll have 4x out here, and combining the 6 and the 1, we'll have 4x plus 7 all over x plus 1 squared times x plus 2. And that is the answer for this one. Why? Well, we can verify that we can't really cancel any factors anymore. Since these are all linear factors and there's no same in the numerator and denominator, we can't really cancel anything out. And also, if you want, you can verify this one, but that will require some lengthy multiplication process. So I leave it to you as an exercise. So yeah, before I end this one, I just want to share two exercises that you can work on. Exercise. So the first one is, let's have 1 over x plus 2 over y minus 3 over z. And the second one is x over x squared minus 1 plus 3x over x squared minus x. Now, feel free to share your solutions and your answers to this one in the comment section down below. So that's it, and I hope you learned something from this video. And that's all for this video.